Welcome to Ask and Learn.
Okay, the question here is asking the graph of a function f is shown. Verify that f satisfies the hypothesis of Rolle's theorems on the interval 0 through 8. Then estimate the values of c that satisfy the conclusion of Rolle's theorems on that interval. So here I've drawn the function f, and essentially there are three conditions for Rolle's theorem. So the first condition, as I've listed here, is that f is continuous on the closed interval from 0 to 8. So what it means to be on the closed interval is that it includes the endpoint 0 and 8, which here it is obviously continuous because we can essentially draw this function without picking up our pencil, or that the limit at all these points exists. So that is continuous. We got that. For difference, so the second condition is f is differentiable on 0 through 8 on the open interval from 0 to 8. So this does not include the endpoint, because if it did include the endpoint, technically the derivatives don't exist because the functions stop here and it's essentially like a curve, a sharp point. So we don't include the endpoint, but since this function is smooth, we can also assume differentiability. So it is differentiable on 0 to 8. And the last condition is that the endpoints of this function equal each other. So essentially here at f of 0, f is 3, and at 8, it is also 3. So we know that this is a true statement. Now, these are just the conditions to satisfy the Rolle's theorem. So what does the Rolle's theorem actually tell us? Well, once these three conditions are actually satisfied, the Rolle's theorem tells us that there is a c in f of x such that in the interval a through b, which in this case is 0 to 8, such that f prime of c, so one of these numbers c, is equal to 0. So what does that mean? Well, that means that the tangent line at one of these in this function is equal to 0. So essentially, this is saying that when Rolle's theorem is satisfied, we know for a fact, like 100% sure, that there's at least one c, one number, one point along the x-axis on the function where the derivative is equal to 0. So let's look for those derivatives. Well, we see one right here at x equals 2 because we can draw a straight line right here. Well, that's not very straight, but you see my point. This is a straight line at x equals 2. So we have 1 at x equals 2. And if we look, actually, it's also at x equals 5. We have another straight line, another tangent, such that the slope f prime of c is equal to 0. So those are the 2 points in which those are the two values of c that satisfies Rolle's theorem.